This is adding fractions with different signs. What that means is that our fractions could be positive or negative. And then these are going to have different denominators, which of course makes it a little bit more challenging. So let's take a look at the first set of problems. You can see the denominators are not the same, but in order to add fractions, they must be the same. Well, that's not a problem here. So what we do is we look at the first one, 8 and 4. And this is what you do. You check. Does the smaller number go into the bigger number? Does 4 go into 8? Yes, it does. It goes 2 times. So I'm going to multiply this by 2 over 2. And then I'm going to add my new set of fractions. So we have 5/8 plus, and now this is 2 times 1 is 2/8. And you add that together and you're going to get 7/8. Does 6 go into 8? No. So what I like to do is I just keep adding. I'll do way over here. I keep adding the bigger number until I get a number that the smaller number will go into. 8 and 8 is 16. Does 6 go into 16? No. So add another 8. 24. Does 6 go into 24? Yes, that's it. So I'm going to multiply 8 by 3 to get 24. 3 over 3 is equal to 1. And 6 I'm going to multiply by 4. So 4 over 4 equals 1. Multiply anything by 1, you don't change it. So our new fraction is going to be 4 times 5 is 20 over 24 plus 3 times 3 is 9 over 24. Add those numerators together, keep the same denominator, and in algebra you can leave your fraction as an improper fraction, which makes it a whole lot nicer. All right, does 6 go into 9? No. So I'm going to take 9 and add 9 and get 18 and check again. Does 6 go into 18? Yes, so that's my magic number. Multiply this by 2 over 2, multiply this by 3 over 3, and I'm going to get 15 over 18 plus a negative 16, our first negative, over 18. And 15 plus a negative 16 is negative 1 over 18. Always keep your denominator the same. Now in algebra, it's a whole lot easier when you're using the excuse that you're adding signed numbers. So we're going to turn everything into an improper fraction. Plus in algebra, you leave your answers as an improper fraction. So 4 times 4 is 16, 17, 18, 19 over 4. Oops. And I'm going to add to that a negative. 7 times 3 is 21, 22 over 3. Does 3 go into 4? No. So what I'm going to do is I'm going to take 4 and add 4 and get 8. Does 3 go into 8? Nope. Do it again. Add another 4. 12. Yes, that's it. So here, I'm going to do this in a different color. I'm going to multiply this by 4 over 4 and this by 3 over 3. And the thing is 3 and 4 are relatively prime, which means they have no common factors. So it's going to be the product of the two numbers. And that will always work. But you wouldn't want to use 54 for the third problem. It's just too much work, and then you have to reduce it in the end. All right, so 3 times 19 is going to be 57 over 12 plus a negative 88 over 12. And 57 plus a negative 8, well, those numbers are different, and we're going to get negative 31 over 12. You just take negative 88, and we add 57. So we're going to get negative 31 because the absolute value of the 88 is larger than the absolute value of the 57. So that's your answer for that one. And for this one, let's see, 3 times 5 is 15, 16, 17, 18, 19 fifths, plus 5 times 3 is 15, 16, 17 thirds. They're both positive. 5 and 3 are relatively prime, so once again, I can multiply this by 5 over 5, and this by 3 over 3, and I'm going to get another 57, I guess. No imagination in this problem, I guess. Plus, and then 17 times 5 is 85. Over 5, and if I add the two numerators together, I'm going to get 142 over 5. All right, this next page, what I'd like you to do is copy the problem, put it on pause, copy the problems, and then when you're done, on the next page, you can check your work. All right, so this is what I did. The 3 and the 6. 3 doesn't go into, 3 goes into 6 2 times, so I multiply by 2 over 2. That's my number here. And then working across, working down is much more ideal, but for the sake of this tiny little page is what I had to do. So now we have the fraction 4, 6, and 5, 6, same denominator, and 4 and 5 is 9 over 6, which we reduce to 3/2. Now we have, what's the problem? 5 ninths and negative 2/3. 3 goes into 9 3 times. So multiply that by 3 over 3, and we have 5 ninths and a negative 6 ninths. Combine your numerators, 5 minus 6 to get negative 1. Negative 1 over 9. In green, 5 ninths plus 2 6 was the original problem. 6 doesn't go into 9, so we keep adding 9 and 9, and we get 18, and that is the magic denominator. So we end up with 2 times 5 is 10, 2 times 3 is 6. Add those together, really kind of cramming things in here. We get 16 over 18, which can be reduced to 8 ninths. We start with 5 eighths plus a negative 7 twelfths, get a common denominator of 24. And so we end up with 3 times 5 is 15, and 2 times negative 7 is negative 14. 15 take away 14 is 1 over 24. Change from mixed numbers to improper fractions. So 2 times 5 is 10, 11, 12, 13 fifths, and 7 times 3 is 21, minus, we have 23 thirds, and 13 minus, oh, we don't have the same denominator. Sorry, this is a real long problem here. So we're going to have to find out what it is. It's going to be 15. So to get 15, it's going to be 3 times 5 right here, and this is going to be 5 times 3. And we end up with 39 minus 115, negative 76 over 15. Same thing here. 2 times 5 is 10, plus 2 is 12. And 4 times 4 is 16, 72, 19. We don't have the same denominator. These numbers are relatively prime. So I'm going to multiply 5 times 4 and 4 times 5 to get 20. And my numerators are going to be 48 plus 95, 143 over 20. How'd you do? This workforce product was funded by a grant awarded by the United States Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the U.S. Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites and including, but not limited to, accuracy of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.